Welcome to progeCAD Basics for Beginners. This is dimensioning your drawing. To find links to any downloadable resources available for this video, make sure to check the description box below. For this session, I'll briefly look at the progeCAD sample drawing AEC-Plan Project Sample, which I already have open. I've also created a simple mechanical bearing in a new drawing to show you various types of dimensions. Dimensions in progeCAD are also a style-based entity. From the sample file, I'll open the Dimension Style dialog from the small icon in the corner of the Dimensions panel in the Annotate tab. Looking at the styles listed, there are 3 at the top that I want to call your attention to. Each is the same name with a different number at the end. There are numerous methods used to dimension drawings. One of the oldest and most commonly used methods employs styles as we see here, where the number represents the intended scale of the viewport that it will be displayed in. Dimensions are placed in model space with this method. The number is the inverse value of the scale. So, the one labeled 96 is for 1/8 inch equals 1 foot views. The 48 is for 1/4 inch equals a foot views. It's probably easiest to do a quick internet search for these, but the formula is to invert the fraction. In the first case, 1/8 becomes 8/1, or just 8, and multiply it by the 12. That gives us 96. Longtime CAD users can usually just glance at the number and know what the corresponding scale is. Why is this done? To match the text and dimension elements when viewed at scale on a 1-to-1 drawing, a piece of 3/16 inch text must be drawn 96 times larger than 3/16, which becomes 18 inches tall in model space, but viewed at 3/16 on the plot. This same scaling and style naming concept is often used with text and annotation as well. To show you all the settings for dimensions, I'll click on Modify for the current style. I have 7 tabs at the top. The control for the scaling I just described is in the Fit tab. Moving quickly through the tabs, the Lines tab defines how the line work is created. After that are your symbols and arrows. Notice you have a lot of options for your terminators. Next is what style you'll use and other parameters. The Fit tab has to do with placement and scaling. Next is the information about the primary units you'll use. Then you can set up if and how to use an alternate such as metric. And finally, select if and how you'll implement tolerances. The last 2 tabs are disabled by default. I'll cancel the style box and move over to my new drawing with a simple bearing already drawn. I have a dimension style that just uses 2 decimal places of accuracy, so I'll select it from the Dimension Styles pull-down in the ribbon. The dimension tools are in the Ribbon's Dimensions panel. I'll show you the basics of the most common types. Also, I have already set up my layer to use a separate dimensions layer. The most basic is your linear dimension. It's the default displayed in the panel's icon. I'll click on it to launch the command. Notice the prompt. This prompt will be common to nearly all of your dimension types. You can either specify point to point or press Enter to select an object. I'll show you both. Let's dimension the overall base of this bearing. Using an endpoint eSnap, I'll select the lower left corner, then move over to do the same for the other corner. Next, you are prompted for the location of the dimension. I'll pull down and click to place it. I'll erase the dimension to show you the object method. Using it will cut out the steps of clicking each point. Again, launch the linear dimension, press Enter, then I'll select the line representing the base of our bearing. progeCAD will calculate the start and end point and then go straight to the prompt to place. I'll click to do so. The next type is in the icon pull-down. It is for aligning with angled entities. I'll click it, press Enter, and select on one of the angled sides. Next is an angular dimension. I'll select the 2 lines on the left that define the angle. When prompted to place a dimension, notice that visual and values change based on the direction you go. I'll click to place the 61-degree value. Next are the radial dimension types. All of these prompt you to select an object instead of giving you the option of points. The first is a radius dimension. I'll select the outer circle and place the dimension. Next is the diameter dimension. I'll select the inner circle and pull out to the left to place it. The last type is arc length. I'll select the top arc and place the dimension. That's pretty good, but I didn't get the two hidden holes on either side. To demonstrate two dimensioning styles, I'll erase the 8-inch base dimension and demonstrate both. These are called continuous and baseline dimensions, and both start with an existing dimension. I'll create a linear dimension from the left endpoint to the endpoint of the first center line. Now, I'll launch the continuous dimensioning tool and select the linear dimension I just put in. That is our starting point. From there, it's just a matter of selecting the next point and the next point until you're done. Click Enter when you are. For the baseline style, I'll erase all three and start over again, creating our initial linear dimension. Launching the baseline command, I'll select the remaining initial dimension. Continuing across the bearing, I'll select the center line of the side of the hole, the center of the circles, the center of the line to the right, followed by the endpoint. I've left out one of the tools in the panel, and that's QuickDim. It's a tool that can be quite useful in the right situations, but not always. With it, you define the entities to be dimensioned with a crossing or inclusive window. It will literally find all of the geometric points it can, dimension, and create the strings for you. I've returned our bearing to its original condition. Let's look at how QuickDim works. I'll launch the tool and start with the bottom strings. Notice the prompt says select geometry to dimension. I'll use a crossing window along the bottom and then add in the outer circle, then press Enter to accept. Being prompted to place the dimensions, I'll do so. Notice the result. That's a lot of cleaning up to do. Plus, it considered the edges of the side holes, which we don't want, so I would have to start over with their layer turned off. I'll do it again, this time going vertically, selecting entities individually. After placing, it didn't know to include the top arc as the overall value, but otherwise it did pretty good. As you can see, QuickDim can significantly speed up your time placing dimensions, but it will become up to you to choose the right time to use it. You can find out more information, download their 30-day free trial, or purchase your own progeCAD license at www.progecad.com.